What's up guys, Shawnthebro here, and today we're going to be going over the blueprint only input buffer part 5. And this will work for any of the series, this will work in any Unreal project. So this isn't related to one of my specific series, just a little mini series if you want to do things in blueprint instead of code. This will allow you to use the input buffer system that we set up in the code in blueprints. It is probably the most complicated system we have at the time of recording this. And so I've been recreating the thing in blueprints for those of you who are working in blueprints for your entire project or just prefer working in blueprints and would like to understand how to set it up. So I've been deconstructing it and putting it into a blueprint only method. In today's episode, part 5, we're going to be going over finishing release inputs, actually using them in our input buffer. Alright, so as a demonstration, I have 3 attacks, 3 inputs, or 3 commands that I can use. So let's say my first one is just 2 buttons, one and then the other. And I do this little animation that I bound to it in one of the earlier episodes. That's simple. Then we set up one that used our input axes, so I can use my forward back punch. I'll do it really quick, but you see command 2 appeared in the top left. The text is kind of being overwritten by the quest text right now, so here I'll show you the output log and go down to the bottom and you can see my information. Okay, so if I do, that's my first command, there we go, you can see command 2, and command 3 is to do this right here, where I am now going to press the first input, release it, and then use another input. So we're going to do a lot quicker than that, but just like that. It's actually going to force me to release. Look, if I press the one input and then the other input, nothing happens. If I press release press, then I get command 3. That's what we're going to be doing today. Before we get started, if you want to get caught up in the series, I'll go ahead and link you to this episode right here. This is the first episode of the blueprint only input buffer series. So you can check that out and get caught up to where we are now. Alternatively, if you're interested in the actual game you see on screen that's in progress right now, then I'll link you to the third-person tutorial playlist, which will show you everything that we've done to date to get to this point in the series, where we can do everything that you're seeing now and a lot more. Alright, let's get started. Since this is the blueprint only input buffer, we're not going to be using any code today. So I go to where my base character is held. I call it base character BP. Let's start in the event graph. So I'm going to clean this up live. I've been doing this more frequently, where I have the old logic in here and I show you what I replace with it, because since I do this logic beforehand, sometimes it gets confusing to show what I'm replacing. Let me step through it one step at a time. First things first. We have an input action called add input to buffer. And what this is an input action in our project settings input that is bound to the any key event. Now, this is good and it was working for our add to input buffer, but the problem with it is it doesn't always pick up on those other inputs. If I'm holding one and I don't release it and then I press another key, it will fire again. The input action can only be fired so many times. So if I'm pressing it, if I'm spamming different buttons, it's only going to trigger so many of those. It's not going to pick up every input. However, if we separate the logic where every single input action calls a function, then it will track every single time any one of these is pressed, no matter how much I spam it, or at least even if I spam it as hard as humanly possible and as fast as humanly possible, I still will get each and every event captured. I've disconnected it. I'm going to leave it in my project settings because I may use it in the future for other things. But I'm going to get rid of the actual input action event for that. Now, what we need to do instead is plug in another event for that. And I'm going to make a custom event, and we're just going to call this everywhere that we want to call it. Simple enough. So if I am to right click and add custom event, you can call it whatever you want. I called mine perform input logic, and I've given it 2 input parameters by clicking the plus sign. One is called key and one is called status. So this could be input, doesn't have to be key, because it could be for a gamepad, could be for a controller, might not be an actual key on a keyboard, but but it will still count either way. So you can call it button, input, whatever. I'll leave it key for now since I'm only worried about keyboard. And status. Status is relating to our input status that we set up in the previous episode. But to find this, just go to your input status. Enum right here. And remember, this one is the one that has pressed, released, and held. All right. Now we need to update this, or update our logic in our event graph to call this event instead of calling that add input to buffer event. So what I'm actually going to do is take all my individual events that can be related to the input buffer, and I'm going to call this function with the proper data. So it looks like a lot, but it's really not. Basically, if there's anything that I'm going to bind in my setup input actions or setup input axes, all these bindings I've done, then I want them to be considered something that could trigger something in the input buffer. So it could be considered for a command. And if that's the case, that's exactly when I want to track it. Now in this episode, I've actually disconnected setup input axes. There's nothing wrong with setup input axes. It actually still will work perfectly fine. I've gone ahead and used input actions for these new ones now for my forward, backward, left, and right. In this scenario, I don't have any cases where I need to use an input axis over an input action. Doesn't mean they don't exist, and we can definitely use them. However, I'm not going to be using them now, so I want to show you this method. You can use your actions, or you can continue to use the axes. If you're familiar with my fighting game tutorial series, we have the input buffer, and I do use the axes, actually. So they're perfectly viable, and there's a lot of complicated stuff that goes on with them that can be useful. I don't think right now it's necessary, but again, I'm going to show you both methods so you can use whatever you want. Go into setup input actions, like you saw here. If you're going to follow along, I'd recommend disconnecting the setup input axes. Again, not really an issue to use these, but we don't want to do them both. We don't want to have the input actions and the input axes. We should do one or the other. So what I'm going to do is I'm just going to scroll over, and here are all the ones I've got. I have jump through special action, special move 2. Okay. But I've added menu up for forward, menu down for backward, menu left for left, and menu right for right. Now, if you're not following the third-person tutorial series, those might not mean anything to you, so it's fine. I'm going to show you. So I have these menu keys, is what I was calling them, because these are my controls on my menu. Funnily enough, they are the same controls that I use to move, but these are just input actions, and they don't take into account how much I'm moving in any given direction. So I just have up, down, left, right. So it kind of simplifies things. You can use any input actions you want, but just make sure if you're going to be using them in the action mappings and in the command buffer, you're going to want to add them to this function, setup input actions. So I go to the last one that I had, which is this. And actually what I did was I just copied from the contains string to the add to input map. And you'll want to take the reroute nodes too. But if you don't want to copy, it's super simple. Let me just refresh your memory on what's going on here. So we have this function called add to input map. And what add to input map does is we have an input to input type map, which converts an actual input, such as the W key, to a type. So we convert it to like walking forward. So if we press W, then W is up, but we don't want to only search for W, because when we use gamepads or controllers in the future, then that would be a bad practice. We would have to check for both W and up on the gamepad and maybe up on a D input gamepad. But if we just convert it to a type, then that's not a problem at all. Okay, so that's what we were doing here. So if we go back into our function, our goal is to add something to the input map. And specifically what we want to do is we want to add our new inputs that we're binding. Okay, so we need to add forward, backward, left, and right. Now to get those, we have to make sure we're grabbing the right input action so we can grab the right inputs, the right keys or buttons that we need to use. So let's take a step back and look how we were doing this. We loop through our action names and then get each mapping by the name. Then, when we're looping through each individual mapping, the mappings are these right here. So these are the action mapping names. Okay, and then we can loop through them and get the mapping. So say I get special action 1. I can get the keys from this. So I have special action 1, this is the mapping, and then my keys are Z. Alright? So in the case of menu up, that's the mapping that we're going to be searching for. I'm going to grab this key and add it to the input map as a type of forward. So I grab the action name off the mapping. I do a string contains, okay? We have a conversion here from name to string. Quite literally, a 2-string node. That's what this is. I have a reroute node that goes the whole way. Look, all these reroute nodes. So just copy it, keep rerouting it, and you're going to drag off this string. This is the name of the action, and you're going to say contains. String contains. You'll get this node. That will be your search in. You need a substring that you're searching for. We're going to search for our action mapping name. So again, we're starting with menu up, so we're going to use menu up. Has a return value for if it found it or not in this string. If it does, we want to bring it out into a branch. Okay, and if it does, we're going to add it to the input map. Now, add to input map is that event that we have in the event graph. Called it plenty of times. Self is the target. Input is going to be, let's follow it down. We have a second set of reroute nodes. It is the key's display name. So this key is the W key, but it has a name, which is just going to be W. And so we need to get the key display name, convert it to a string, and we pass that in as the input here. Then we choose our type, which I'm choosing forward for W. Okay. If it's true, we're good. We don't need to continue farther because we know that the string should not be contained anywhere else. And so I don't connect it. However, if it's false, we go on to the next option to check. So then I search for menu down, and if it's found, we bind it to backward, add it to input map of backward. If it's false, we search for left, and if that's found, we add to the input map for left. If it's false, we continue, and then we look for menu right, and we add it to the input map of right if it is found within that string. Okay, so it's the same process every time, but I just want to show you I updated that. And like I said, since I'm using the action mappings in today's episode, I disconnected the input axes just to make things less confusing. Now, once we've done that, we can go back into the event graph, and we have to go and set up our input actions for each of these and call this function. We had to do that first because if we do that, we can bind them in this input to input type map, which we're going to need later on. But this part where we're actually using the input actions is so we can call the perform input logic and if we pressed or released it. So go through and for all the action names that you search for, jump, attack 1, special action 1, special action 2, menu up, menu down, menu left, menu right, or whatever it may be that you are using for your names, go ahead and grab those input actions. So see, I can do input action, and I have all these options. So jump, menu up, down, left, right, all these guys. So grab all of them. They will have a pressed and a released and a key that they give. All these are going to follow the same exact procedure. So I'll show you with the jump. We have input action jump. Now we're going to call our perform input logic event that we made earlier, and we're going to pass along the data that we want. So we just type perform input logic. It'll come up like this. Target is self because it's on this character, and we're going to give it a key. What key do we want? We want the key that comes from the input action. Okay, so take the key from the input action, pass it into key. And for the status, you just pick what type of status it is. If it's pressed, then we want to use the press status. If it's released, we want to use the release status. You can just change it with this drop down. Jump does this, attack 1 does this, special action 1 does this, special action 2 does this. Right now, I'm using the input action, but if you wanted to use move forward, you could do the same thing. It would just be a little bit different because you have to check the value first. Check if it's, say, greater than 0 or less than 0. If it's equal to 0, then that's when you release that input that you had. It's a little bit more complicated. Like I said, that's why we're using the input actions, but this will be good for now. We see menu up does the same, menu down does the same, menu right does the same, and menu left does the same. Like I mentioned with move forward, you could do the same with move right if you want to use the axes. There's one more important thing with these input actions. When you click on them, you'll get some options in your details panel. Consume input, execute when paused, and override parent binding. Now, I have a lot of these bindings in code because in my third-person tutorial series, we use code to perform this logic. I don't want my third-person tutorial series to not work because of the blueprint-only input buffer series. But what we can do is we can have the event both in the code, which I'll just show you. We're not going to be changing anything in code, but see, I bind to jump in the code. Okay. And we also have one in the blueprint now. If we left it here and don't uncheck override parent binding, then what happens is the code one gets ignored. The blueprint one is chosen here. So we want to check or uncheck override parent binding for all of these. I actually did not do it for menu left, so that was my fault. But there you go. Make sure that these all have the override parent binding set to false. Once they do, then both can coincide and it'll be much better that way. Now, perform input logic is being called from all these individual buttons, which makes our input buffer a little bit nicer to use and less prone to errors. Now, it's still really ugly here, and that's because here is my remove old inputs from buffer logic. And we were doing this whenever we have right now an arbitrary ugly 0.2 seconds. So once 0.2 seconds have passed, we want to remove elements from the input buffer. Now, for now, I'm sticking with the time. We're not swapping over to frames, and I'm not going to show you the circular input buffer just yet. So this is fine, but we need to be able to do this when we're pressing an input or when we're releasing an input. So before we had add this back for a second, add to input buffer, and we had pressed going into this logic here, and released I just had into a reroute node down here. It wasn't connected yet because it wasn't set up. Okay, so remember, we're getting rid of that, but really I want release to also remove inputs from the input buffer, because now we have some commands. Okay, I'll go into this more in a few minutes, but we have a command where we actually have to release an input before pressing another if we want to execute this command correctly. And so now releasing also has to remove old inputs from buffer. All right, so what I've done is I've copied this. This logic has not changed. So this is my removal logic for old inputs, for stale inputs, okay? And so what I did is I copied it, I made a new function right here, plus function, and I called it remove old inputs from buffer. I pasted it in here. Not going to go over this again because we've gone over it in the other blueprint only input buffer episodes, but essentially we go through the input buffer. If the input is too old, then we tag it as an input we're going to remove. And then we loop through and remove each individual element. Then we clear the removal array and go on and then check the new ones that we added and check against them and see if we performed a command. So we're going to be calling this instead of doing this logic right here. So I'm going to delete all of that logic. Okay. It's going to be a little scary at first because it opens up this huge gap right here. And we're going to have to clean it up. So give me a second. We'll clean everything up. I'll do it here with you. Get rid of some reroute nodes and make things look a little bit nicer, a little bit cleaner. Let's see, we don't need this. Whoops. Let's not move that. Actually, take even better. Do it like this. go. Let's see if we can do something like this. Don't want to take too long, but it is important that it looks good. That's probably good enough. It's not the best, but it will do. Okay. So now, instead of just going directly to our logic, we take the status that's passed into each of these perform input logics, and we can do a switch statement on it. Okay. Once we do this, we'll have pressed, released, and held. Held we haven't covered yet, but we will cover that. And so otherwise, we have to determine the logic that should occur when we do pressed or released. So for now, we are doing the same logic. We're just going to call remove old inputs from buffer. Okay, that new function we just set up on each of them. However, when we call add input to input buffer, we change our status that we pass in. So we can use the same parameters for everything else, for the input to input type map that was found and the timestamp. But when we call add input to input buffer and we pass along the data, the info status, I have pressed if it comes from the pressed branch and released if it comes from the released branch. All right, now this is a lot cleaner, looks a lot nicer. Now we can go ahead and check out some of our actual buffer comparison logic to see what's in our input buffer versus what's in the command list. So we're going to go to our check input buffer for command. And before we go into this, let's update our commands a little bit, make sure they all look as expected. So I have command 1, which is 2 button presses that we've done in our other episodes. Then I had command 2, which was 3 button presses, and it was using the input axes and a button press. Now this is actions instead of axes, but it will still work the same when we're done with this episode. Then I have another command that was really hard to trigger before, and I've changed it now to have a release input. So we have attack, attack release, and then special move press. Once I have my inputs all set up, and our commands all set up, we can continue into this function, and I'll show you some things that we changed. So we loop through all the commands in our command list, and right away we're going to reset our correct sequence counter to 0. This wasn't as noticeable before because we had less commands and less complexity. It was all about presses. But if you don't reset the sequence counter after every command, if the commands happen to overlap and have, say, 2 commands start with the same input, you could actually then go over from one command to the other and keep your correct sequence counter, and it could execute an incorrect command. And we don't want that. So we're going to right away just, as soon as we go into the loop body here, right like this, as soon as we go into the loop body for the first for loop we have, we're going to reset our correct sequence counter. We're literally going to type set correct sequence counter and leave it at 0. We're going to reset that value immediately. Then it's all the same as it has been. We go into the loop for each of the inputs in the command because we have to manually compare these with the inputs in our input buffer. So we were dragging off the array element of the command input. We're checking the required type and status. Then we're looping through the elements in our input buffer to compare them to that value. So we check and make sure that the correct sequence counter plus the array index is not greater than the last element in the array. Because if it is, we'd cause a crash. So we make sure that it's less than that value. And then we go into a branch. If it is greater than that value, we reset the correct sequence counter because we've already, we've gone through the entire input buffer, but we haven't found a command that fits. We just want to reset. If it's true, though, that means we can actually continue to verify and see if the input buffer has any matches to perform a valid command. So we use the input buffer. We get the input pressed at this new index that we wanted to check. Then we break the data from it and we get the name, timestamp, and status. Now, in the previous episode, we had the name was being equal And if we had the names matching, we were good. So, for example, for the first command here, we have special move pressed and special move 2 pressed. However, we were only checking the names. So if I had pressed special move 1, special move 2, held them in, and I released them at the same time, that would trigger the command. Because it wasn't checking the status, only the name of the type. And so that would have matched. We do have to worry about the status now. Okay. So we want to make sure we do an equal on the enum. And we want to pass in, okay, so we have name is equal to the name of the F command input, and status is equal to the status of the F command input. So F input info break has to equal F command input break for both the type and the status. Okay? Like I said, and. So it goes into this Boolean and. Now, if it does, we're good to go. We found a matching input, and we'll get into that in a second. But if it's false, it's a little bit different now. If it's false, before we were setting the correct sequence counter back to 0 because it's saying we have a misinput. But we don't necessarily have a misinput now because we include released inputs in our input buffer. With released inputs, I basically have to release some of these buttons before pressing the other. For example, if I'm going to do like left and right on the keyboard, say that's my command, well, if I'm going to go to right, I'm going to naturally release left almost all the time. And so we don't want a release input to actually stop our command from firing. I mean, it's pretty natural that you'd press the inputs that you need and then, get rid of the key once you've already pressed it because you no longer need it. So what we need to do, if it's false that the name or the type and the status don't line up, we have one thing we still have to check now, which is we have to check the status of the input. And if it's the player releasing the key, then we don't want to reset the correct sequence counter off that. So drag off your status, type not equal to, exclamation mark equal, choose enum, and you're going to want to choose released, not equal to released. If it's true that it's not equal to released, this means that this is a press. Or a held, but we haven't done held yet. So this is a press. If this is a press and it doesn't match the name or the status that the command is looking for, then we haven't pressed the keys or the buttons in an appropriate way to execute the command, in which case we want to reset it. So we're going to set the correct sequence counter back to 0. If it's false, we don't care about it. We're just going to go to the next loop iteration. We can leave it alone. We can basically just ignore it. However, if this happens to be true, this means that the name or the type and the status have matched between the input buffer, the input that it's looking at, and the input in the command that we're currently looking at. So what we're doing before is we were adding to the correct sequence counter, checking and see if it's equal to the length of the command, and if it is, we know we've properly executed the command. This is good, but there's a few other things we need to add as well. Now, start command doesn't need any changes. It still works the same way as it has, so we don't have to go into there. But if you want to see it, just to get caught up on what mine looks like, you can see it here. We loop through our command, check for the command name that was triggered, and if it's a match, we go ahead and set that command to be used. And I've been printing it out just so you guys can see it for when I don't have animations. You know that I've fired the command properly. However, I have added 2 additional things after the command has been started. And you could do this in start command as well. You do it either here or inside the start command function. Doesn't matter. But once a command is fired, I'm actually choosing to clear the input buffer. It's not required that we do this. However, if we clear the input buffer, then it means we have nothing in there. We don't have to worry about any inputs overlapping with other commands or kind of just sitting there taking up memory. At this point, clear the input buffer. The player has to enter new inputs if they want to enter a new command. It's safe and it's perfectly fine to do. It's up to you if you want to do it or not, because you could actually use it if you wanted to have like cancels, like he used this command and he has to use these other inputs. Say that this cleared some of the other inputs if they were pressing it so quick. You could run into small edge cases like that. But I think in the general sense, it's safe to clear it after triggering a command because it's going to be at least until the end of the animation before they'll probably start doing other actions. So I go ahead and I grab my input buffer, get it, drag off of it, and type clear. Alright, the other thing I do is I reset the correct sequence counter. Now, this will be reset when we go to a new command anyway. However, instead, since we are breaking, we do all this crazy logic, right? Where we bring it to this execution line, which goes to this one, which goes all the way back here and breaks this one. Because of this, though, you could still technically go through more of this loop, which is going to go through more of these functions again. If that's the case, we should just start at correct sequence counter of 0, because at least we will know what we're dealing with. We won't have a leftover correct sequence counter of the maximum value, which will cause it to just fail, and you could skip some commands from time to time because of that. Either way, this is more just for my own record keeping. I know that it's reset to 0 after using a command, so I don't have to worry about it being too high or going out of bounds of the array or anything like that. Alright, and that's it, guys. So that will allow us to use our releases now in our input buffer, our blueprint only input buffer. So we can actually use release inputs without them screwing with the other inputs that we already had, right? We don't want to override the logic that we had and mess it up. So there you go. We can use all of our commands. Our commands can be used a lot more easily now. We don't have to spam it as fast as possible. It's still pretty quick right now because it's only the 0.2 seconds, but it's not ridiculously. We'll get more upgrades to that in the future. Anyway, guys, if you enjoyed this episode and you learned a little bit about input buffers, then please subscribe. Does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to my Patreon members and YouTube membership subscribers. Thank you guys for all that you've done. I am so incredibly grateful for all the extra support. It is really, really awesome that you guys are this excited about the series like I am, and I am incredibly grateful. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. I'd be happy to assist you. It's completely free, and we'll get you sorted so you can continue working on your game. Anyway, guys, like I said, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.